Hi, I'm Nick Chase from Cloud Geometry. Welcome to our series on platform engineering. We've been doing platform engineering since before it was even a thing, and we've noticed several problems coming up again and again. So we built our own reference implementation, CGDevX, which is what you're going to see today. In previous videos, we showed you how easily you can provision your Kubernetes platform with the Cloud Geometry Cloud Native Quick Start Kit, then use GitOps to help manage the infrastructure. We also looked at creating a CI/CD pipeline for promoting your changes between environments. In this video, we're going to shift over to focusing on your actual workloads, from Argo CD to zooming into a single workload to single sign-on and workload isolation. As always, here's my colleague David Fishman to tell you more about it.
Our monitoring solution is powered by Prometheus, which collects data of Kubernetes clusters and its hosts using the pull model. Kubernetes clusters can expose dozens of metrics, and they generally fall under one of the following types. Counters, which show the cumulative count of events. Gauges, that typically represent the latest value of a measurement. A histogram, which takes samples of observations and then counts them up in buckets for visual presentation. And a summary, which samples observations and offers a total count as well as the sum of all the values. We're using the community version of the Kube Prometheus stack, which includes some popular metrics agents like Node Exporter and KubeState Metrics. These expose vital stats for medium to large scale Kubernetes deployments. By default, we provide all the necessary Kubernetes metrics plus a few extras that are now also generally considered standard extensions, such as compute node metrics reported by your Unix or Linux kernel on host system hardware and OSs, state metrics collected from the Kubernetes API server about the state of deployments, nodes, and pods. In some cases, applications need to expose custom metrics. This could be something standard like garbage collection on the heap size of Java, or maybe some custom business metrics. Here's an example. We can collect custom metrics related to your deployment pipeline performance, Kubernetes vulnerabilities, the results of misconfiguration scans, maybe artifact stores, and so on. You can also see the Argo CD cluster version as an example, and we'll talk about the rest of these in future demos. If you decide to expose custom workload level metrics in addition to the Kubernetes defaults, your workloads should expose these metrics in the /metrics endpoint directory of your workload using the Prometheus text-based format or the Open Metrics standard. These endpoints and metrics are automatically discovered as part of our auto discovery mechanism and collected. The service monitor is responsible for this. And as you can see, all you need to do is to put a label on your services with the name expose metrics and the value true. Let's show you how this works. While navigating to the service discovery page, here's a quick recap. So, what have we done in previous demos? Well, we deployed our minimalistic demo app, which was built using Node.js and a popular Express framework. As part of this demo application, we have included Express middleware and built in some popular Prometheus metrics using the Express Prom bundle package that will expose metrics on all routes registered in the application's API using the /metrics endpoint. So, as you can see, this endpoint was already discovered by Prometheus, and we already have some data points being collected from all three environments. So now, let's open our demo application and check this metrics endpoint. As you can see, in Prometheus, we have the same values that were automatically collected. One of the things you'll notice when you monitor Kubernetes is that you'll quickly see it produces dozens of metrics with more nodes and applications added to the mixture as you grow or enrich your environment, it becomes dozens and dozens and dozens of metrics. Without proper visualization of all those, it's almost impossible to make sense of what's really going on. So we've limited the list of metrics that we visualized to those we have found to be most important and useful, but you can certainly add back whichever ones you need at your convenience. Our visualization solution is based on Grafana, which is more or less an industry standard nowadays. We've prepackaged it with a number of very useful dashboards that we handpicked from community dashboards in the open source community and have them customized to include some additional information we think you'll find really useful. We already logged into Grafana with SSO and a read-only user that's available as a default scenario for developers and most other users. So what you see here is a set of pre-installed dashboards. The general idea behind dashboards is that you have a global view and then you can zoom in to specific areas or a particular use case to get a more granular view. We try to follow the same logic with each additional workload that we're monitoring. We like to call them views because they show information on your Kubernetes cluster and workload from a particular perspective at a particular zoom level. In this video, what we're going to focus on is core metrics, but as you can see, we can also have others for specific services with views for Argo CD, Trivy, Tracy, and others. Let's have a look at some core views. With the global Kubernetes view, you get a global view of the cluster very quickly. So you can spot any unusual patterns of resource usage like CPU or memory or network, maybe unusual numbers of resource types, misconfigured application resources like requests or limits, etc. The next thing you could zoom in on is the services of a specific platform in your workload environments as they are all isolated from one another using Kubernetes namespaces. In addition to the metrics we had in the previous view, which are now limited to a specific namespace, you can also see the state of pods and pod replicas and persistent volumes in their capacities and inodes. From there, let's go look at the Kubernetes node view to get detailed information on particular Kubernetes nodes, where you can also check for unusual resource usage. You could track affected pods in case of node failure and look at operating system metrics. From there, you can go to one level deeper and get a detailed view of your pods and containers, looking at things like node mapping, IP addresses, and you can size your container by comparing real usage versus requested usage versus usage that results from resource limits that you've configured. And if you're really curious, you can have a look at Kubernetes internals. We'll give you a view of Kubernetes API server health with request statistics, a list of deprecated Kubernetes resources, and a core DNS health check, and look at any other unusual issues. In addition, we offer platform services specific dashboards like this one, which shows Argo CD, because it's a core part of the delivery pipeline that we have presented before. So in Argo CD, you'll see the application status, sync failures, event and resource counts, the actual resource usage that Argo CD consumes, etc. Or you could look at the ingress controller dashboard where we're using Nginx as the ingress controller. We can provide here in these views data on the status of requests, data on latency, count, and all kinds of other resource data zoomed in on that specific resource. All right, now let's pivot a bit to workload-specific dashboards. We're going to provide views such as the use method view, which is widely used to analyze the performance of the system and identify bottlenecks. There's resource data for CPU, memory, network, disk, utilization as the percentage of time that the resource was busy, saturation is the amount of work that the resource might have to do, like queue length, and a count of error events. This is all tracked And that's why they call this method use. There are a couple more, but before we discuss them, we want to show you how you can edit dashboard. And this is a good opportunity to talk about access management. As you may have observed earlier, we're logged into Grafana using Vault, similar to the way we previously accessed Argo Workflows and Argo CD. And that's because we've already pre-configured Vault for you as the OIDC provider for Grafana. This way, user management is much more coherently centralized. We've also got RBAC pre-configured and mapped to the group that the user belongs to, so the developers won't be able to inadvertently change critical Grafana configurations or delete views and alerts. Here's another example where we open a web browser where we logged into Grafana with admin permissions. So we'll navigate to user management, and you can see that we have other users who are using Grafana via the Vault OIDC. And so now let's temporarily upgrade our permissions and go back to our previous session. And as you can see, we have the editor role activated, and we'll use that in the next step. Let's dig into alerting. Alerting is crucial to monitoring because that's why you're monitoring. You want to see if there are problems both live and historically. We ship our toolchain with the most critical alerting rules enabled by default. They're configured as code via the platform GitOps repository. Now, you, of course, can add some new ones of your own. Based on our experience, the best practice here is to manage all the alerts as code using a GitOps approach, so you can have monitoring as code. In this case, for simplifying the demo, we're also time limited, and so we're not going to create too much, but we are going to create a new alert via the Grafana web interfaces. Now, for most users, it will be easier to configure the alerting rules and dashboards using the Grafana UI and then export them as code and put them into the GitOps repo and add that to the release workflow. That's easier than editing configuration files directly and, generally speaking, safer. So now let's open our demo application and refresh one of the pages a couple of times. Our activity in this app triggered some API calls that changed the values exposed by the application, and then we'll see these metrics visualized momentarily. To do so, we'll open workload-specific views created especially for Node.js-based applications, as we discussed earlier. We'll also zoom into the development environment, which we just accessed, in order to filter out metrics from the other two environments that we have. You can see here there's a spike on requests that was caused by us accessing the application. Now a quick test. We'll use Apache HTTP server benchmarking tool with 50 concurrent connections that generate 1,000 requests. In a couple of moments, it's actually 30 seconds, which is the recommended metric collection interval, you can see how our small test had an impact on the demo application. And that was reported back both as increase in resource usage and the number of requests per second processed by the application. So now let's simulate some more user activities by running requests with a benchmarking tool. So now imagine a situation where we want to provide a good experience for one of our application users. And we want to monitor the request duration of all the API calls on the assumption that that's really the most critical metric having a direct effect on users. We'll show you first how we do so with the web UI. We navigate to widget details and from there to alerts. And now we're going to update the expression that's used to calculate the metrics and set it to a request duration from all the containers over the past 2 minutes of greater than 1.5 seconds. We're going to evaluate that expression each minute and trigger alert when we cross a threshold by more than 10%. With Grafana, you'll be able to notify on any alert triggered by using different types of channels like email or Slack or PagerDuty or other kinds of what they call contact points. We already have one configured for our Slack channel by default, so notification on any alerts triggered will automatically appear in the Slack channel. Now that it's all set, let's go back to the dashboard. As you can see, the alert evaluation is pending as we're still running the benchmark, so we'll give it a couple more minutes to update. And an alert is triggered. That's also indicated on the widget in the dashboard in this view. As per our configuration notification on this alert, it's also sent to Slack, and you can see it here in the Slack application. So let's stop the benchmark tool and we'll wait for the alert to resolve. In parallel, let's look at the ingress control metrics. Here you can see an increase in request response time and latency corresponding to the spike on our Node.js application view. You can also take a look and see an increase in resource usage via the Kubernetes pods view that we had showed you earlier. Let's go back to our Node.js application view and again, zoom back in to the development environment. As we introduced some delay by the metrics collection mechanism, we'll wait a couple of minutes for the data update. And now you can see that the alert is resolved and we should receive corresponding notification in the Slack channel. Wait for it. Here we are. There it is. Now you can see that this Kubernetes beast of thousands of metrics can actually be tamed with pre-configured and pre-built metrics collections and visualization in this open source based solution. With very little effort, you can add custom dashboards and views, you can create new alert rules, you can even create more sophisticated custom metrics. You can do all this without really having to invest overhead and toil in user and permission management because that's all done for you. This makes the problem of workload monitoring much simpler. It also simplifies troubleshooting when something goes wrong, because it's not if something goes wrong. There's something always that's going to go wrong, and you want to be prepared with good metrics, good alerts, and good observability.